Hello, everyone. Welcome to Hang-Ons with RAKStars. Happy to be once again with all of you. I hope everything is doing great today. If this is your first time joining this session, a warm welcome for you. Happy to have new community members joining this community space. Just a summary before I start. This is basically a community space where we share with passionate with passionate RAKStars, which are our community members in the RAKwireless community, and we talk about their hacks, their cool projects they are working on, and also many other experiences. I am Maria Hernandez, Developer Relation Lead at RAK, and next to me, I will be moderating this session with Jose Marcelino.
Hello, everyone.
And before starting the session, I would like to highlight also one thing. If you are here during the live session, feel free to ask any question in the comment section. I will be keeping an eye on the chat every time a question pop-ups or during the Q&A session that we will have at the end of the session. And additionally, I encourage you to stay tuned and ask questions during the session, mainly because our guests have many things to share with all of you. And secondly, because we are going to be giving away some rack swag between all of those who ask questions. So that's all for before I start. In today's session, we're going to be chatting with two awesome guys who are super passionate about IoT, like many of around here. And they have teamed up to create amazing things together with experience in embedded system, telecommunication, and software development. They decide to join forces and develop a LoRa Analytics platform for identifying issues and optimizing network development performance. And also, they develop a cool multi-radio IoT hardware and a pocket-sized Wi-Fi connected LoRa Gateway, which is really cool. These two masterminds behind all of this development are Dimitris and Ioannis. Welcome, guys.
Hello.
Hi, Maria. Thank
Hi,
you.
hi.
Thank you for the
Amazing
introduction.
No, you have many cool things to share today, and like all the things that you have been developing during the past year are super awesome. So I'm super excited about all the things that you are going to present us. And yeah, just to start, like something that both of you have in common is that you are super passionate about IoT technology, as I just mentioned it. And additionally, that you are two guys that are always looking for different ways to make IoT easy and accessible for everyone, as we do it here at RAK. So just to break the ice, can you share us more a little bit about yourself, like your education, your background, and how and when did you start thinking with IoT technologies?
Yes, sure. I'll start by saying that this type of blushing is not high saturation. It's you giving a very, a very thoughtful introduction. So yes, I'm Dimitris. I'm half of the team of Kudzu Technologies. I've been a computer engineer for about 15 years now. It's been quite a few times. I started studying on a typical polytechnical university in Greece. I did the jump to embedded systems from VLSI to embedded systems exactly because I had the feeling that embedded systems is actually what brings technology much closer to normal people and all these type of use cases that today we see with IoT. Then I just moved out of Greece, moved to another university for master's degrees, and I've been working. I was working in the Netherlands, where I had the luck to meet all these LP1 technologies right from the start. And yeah, more on this later on.
Super. And how about you, Ioannis?
Yeah, hello. I'm Ioannis. I'm the other half of Kudzu. So I have a quite diverse background. I'm actually into creative things, like overall. To be honest, I couldn't really decide what would be exactly my profession while I was young. So I was playing with electronics since I was a kid, like starting from like alarm things to the house and things like this, like when I was like 10 years old. Eventually, I invested in computers and like electronics. That was like my hobby at the time. So I thought like by the time I was about to decide for a degree, I knew electronics, and this was like my tool. So that's why I majored in something else creative and engineering, which is architecture. So I'm actually, my major degree is architecture engineering. That's like my, let's say, education degree.
Okay.
But yeah, in the meantime, I was invested heavily on my hobby and my spare time, and that actually started to pay off later. So a few years later, while I was still in architecture, I went to CERN as a summer student. And this was like my opportunity to learn, to actually apply my knowledge of electronics and engineering and computer science into reality. And from this point onwards, I started a path where I started to invest myself more in embedded systems and software. That eventually became my profession. So I kind of like pivoted, let's say, at the time into something more interesting there. And yeah, my expertise varies from software engineering into embedded systems designs to architecture. So.
Okay. That is super nice. Like you are building architecture in another way.
Exactly, architecting both systems and buildings at the same time.
So you have Ioannis coming from real architectures into the architecture to the embedded systems, and I'm coming from computer architectures to architecture to embedded systems.
Nice,
So
super.
So just merging there.
Do you split both? Like one designs the hardware and the other the software, or how does that work? How does the split work?
Well, that's something I usually joke about. I would say, I was saying to Maria also that since we are RAKStars here, I'm the lead singer of the rock group, and Ioannis is doing, all this soloing, writing all the software and everything. Yes, we do actually. I'm more on the LoRa side. This was my dream when we started building Kutsu technologies. Ioannis is the guy who came and glued in all that I had in mind to do in hardware side and on embedded systems. So a little bit of what you see today, when it has to do with LoRa, let's say it's me, and when it has to do with all the rest of the stuff that Kudzu does, which is a lot, is probably Ioannis.
Got it.
Okay.
That's actually, yeah. That's like an interesting story how we actually met with Dimitris. It was like...
Yeah, I wanted to ask that question. How do you met each other?
So yeah, actually... so like this is also like where Sprout was started from, let's say. Okay. So 2 years ago, I was I'm still part of like a member, like a club in Thessaloniki, in a hackerspace called T-Lab. And then this is like where I started learning about LoRa and started playing with LoRa. That was like a LoRa rookie in that particular domain. And then we quite frequently had the need of creating like something we can play in the lab, try to work with. And this is the first time we created the first micro node, let's say, there at the time. It was the hardware of my design. Actually, I can even show you later, which is like the very first device that gave birth to Sprout eventually. And this is how this was like a first very small powered like LoRa device that you can use in your pocket, and you can still prototype on it. That was like the biggest thing. And that you could just, for example, create a temperature sensor like in a few soldering things. It was like practical for playing around with, like big components, still SMD, so you can learn how to solder those kind of things. And this was like the first device. Then I started to let's say, sell it as part of the club. And that's where I actually met Dimitris. So Dimitris found me through that process, said, hey, you seem to know about your LoRa stuff, and I would really like to jump into more the hardware side of the thing. Say, we would like to collaborate. And as we were discussing with Dimitris, we found out that we have more things in common, actually. So we share the same vision about how the LoRa network should be. We learn the same problems of designing embedded systems from scratch. And this is how we decided. So we incorporate together into like having this whole thing made and done till now.
The punchline, to be, if you allow me to be a little bit more precise, the punchline was, I remember saying to Ioannis, I want to build an embedded system which embeds all the pain and suffering of embedded system developers. So this is what you're gonna see today. Remove all this type of pain of developing embedded systems and actually let the device do this for you.
No, that is amazing. Like a really good story. And that is awesome. Like that is the kind of opportunity these like community spaces offer to the members of it. Like you met each other in the community space, and now you are running like a company that are building like amazing things, and is making the things easier for everyone who is using it, and also for you guys, like, which is awesome. Like you build something to make the things easier for you and also for all the people around the ecosystem, which is awesome. And how about like the development of new technologies in Greece right now? Like, do you think they are increasing during the last years, or are you
Well,
the
to be
pioneers
honest,
of that?
no, definitely not. There are amazing stories. There are a lot of things happening around. To be honest, there has been a great, great brain loss in Greece during the last economic crisis, the previous decade. So you effectively had hundreds of thousands of engineers leaving the country. However, if you know the cliches about Greeks, they say they're very connected to the country. So you see a lot of people right now bringing back all this know-how. So there are a lot of things happening. The question is whether it will be, there will be enough space to apply all these things. That's why also we in Kudzu, we started working in Greece. We were very convinced that we should be doing this year. But you always need to, to be able to look outside of Greece, and
Definitely.
there's a whole world happening around.
Totally agree with you. But it is also like super nice to see like how the local things are growing and how the products that you are building is impacting the like technology ecosystem in the country, which is awesome.
Yes, I mean, I remember back in 2015, I wasn't still in Greece. I was still working in the Netherlands. I was coming here for summer vacation and setting up LoRa networks with TTN and Riot, and we could see it growing, and that was, it was really amazing.
So how is the coverage right now in Greece about like the LoRa coverage?
Officially, it's not that dense.
Okay.
You can see there are some networks there are a few networks, mainly TTN networks in main cities.
Okay.
We have been actively supporting most of them, from either what we are doing with the analytics side, but literally with antennas and know-how and stuff like that. Yeah. We are really proud to say that one of the most dense networks is where our headquarters is.
Amazing.
And this is strange because we're not in a big city. We are in an island in the middle of the Aegean, and that's always, it's a little bit weird to see there. But I think it's picking up, and there are a lot of networks being deployed for commercial reasons that you cannot really see where they are. They're not on a map or something. Yeah, it looks like it's picking up.
Amazing. And now, like, let's jump directly to Kutsu. So, can you share like an overview about like the company? And well, you already mentioned like that gap that you notice in the IoT ecosystem when you decide to create this company. So, can you share us more like about the products offered on it and how you are managing everything behind the platform?
Yes, and the tough part is about how we try to bridge these two seemingly completely different products that we have. So on the one side, we are doing LoRaWAN Analytics, which somebody expects it to be, a SaaS software as a service procedure or something like that. And on the other hand, we're doing hardware, and everybody's like, okay, why would you merge these two things? So it all started back in 2017 when I had decided that it was a tough decision to jump from a very advanced market such as the Netherlands back to Greece and do this thing here. But where there's such a great gap in technologies, there's always a lot of opportunity. And we're like, okay, let's do it. We had great faith that we can do it. We started with analytics back in 2017. We started by deploying a few test networks around, because we wanted to see the problems that we knew LoRa would face when it becomes dense, and we wanted to be able to prove this. So we did start building this analytics platform, which actually helps you see how your network really operates. In a short notice, what we see with LoRa, happening with LoRa, is that it's an off-the-shelf solution. Everybody can just, go buy a couple of gateways, a couple of sensors, deploy them, and that's the magic about it, actually. We see it happening with TTN, we see it happen with Helium now. It's amazing. However, when this is used as an infrastructure, there are issues there. You need to take a very good look about what's really happening on your network. But then I met Ioannis also, and I I immediately understood how bright he is and how on this he's gonna be, how devoted. So I told him, you know what, even if we learn what's happening on the LoRa network, we need to let the devices know. And this is how we started building our own prototyping device, which turned out to be a whole-blown hardware software solution.
Yeah,
And
it started by it started by applying like this idea, and then it developed into something much bigger than just like the idea, right? Yeah, just sorry for interrupting you, Dimitris. Just want to say that the whole idea of joining the analytics into the hardware was just like this pivoting point that Dimitris pointed out. So we deployed our networks. We found out that there are issues because when we were running these networks, we had some issues we were trying to solve. And then we decided that, okay, ADR is not enough, let's say, for LoRa to solve this kind of issues. We need something better. We need something more elaborate. Perhaps LoRa might not be always the best in some kind of situations. That's why we thought, for example, why don't we introduce something like a multi-radio device, right? So you can, like, perhaps prefer LoRa as much as you can, but if you cannot really find LoRa, we need a fallback, try something else, because, you know, your single gateway that you're depending on just went away. That's actually quite a frequent thing in low-density networks. That's why we thought of, like, there was no device out there on the market that could have this kind of features we wanted. So we see a lot of systems, a lot of like devices with a dedicated radio, like single dedicated radio, like Bluetooth only, Wi-Fi only, LoRa only, want to go low power with this kind of things. But that's not enough when you realize that if your network goes away, things will be broken down. And like, since like this is also like kind of our motto in Kudzu, so we want to redefine connectivity in a sense that we want to be able to leverage all these kind of problems that might happen in the network into the most efficient manner. So we don't want to be vendor locked, let's say, in one network, or we won't be dependent in one particular network.
Okay.
And this is like how these two worlds join together, like LoRa Analytics and a custom hardware solution, like creating this two faces of Kudzu.
Amazing. And like, you can integrate with any network server available, or you have like something specific to work with, sorry.
When it comes to our analytics platform, we mainly, what we do is actually we grab metadata of your messages. We can grab those metadata from your gateways directly. We can grab them from your LNS server. We really tried hard to make this completely agnostic of both the LNS server and the type of gateway you have. Exactly because we see extremely diverse deployments on the field. I mean, we have even seen people using the same gateways with different backend servers, doing all kind of crazy stuff. So since we just care about the metadata, you can always integrate with all the common, let's say, LNS servers around. So you can integrate with TTN, you can integrate with V2 and V3 of TTN, LoRaWAN, any kind of server that comes with UDP Semtech support. And even if this is not exactly the case for you, you can still run Kudzu services in your gateway so that you feed our analytics platform directly with your metadata.
Got it. Actually, we have like a question here, which is, the analytics work on the edge or in the cloud?
So actually, the analytics work on the cloud. We collect the devices, we collect the metadata from the gateways or from the LNS server, and we analyze them into the cloud. There is a reason for having all this data centralized. Is because we can cross-reference multiple networks in the same area and come up with some like a holistic solution and not just particular to one specific network. Something important to clarify here is that we never care about application data. We only care about the radio metadata, which is the signal quality and the first few bytes of the LoRaWAN header. So that tells us like what kind of message we're sending and all these characteristics of the LoRaWAN protocol. We never touch the data, and we're perfectly fine operating over encrypted data.
Yeah, that is why it's a LoRa analytic platform, because you are taking care about the LoRa metadata. And that's
exactly.
means that you are not providing like an IoT platform inside your platform. Let's say the people can evaluate their, I don't know, end nodes, devices data on your platform.
That's actually a pretty interesting question. Ioannis, would you like to go on with it?
So that's for the future, actually.
Okay.
There is a plan. Actually, starting from the fact that we have this kind of multi-radio device, the next channel is how does someone aggregate the data from these various multiple channels? So we did not want to touch this domain yet because we saw more potential on the analytics landscape. But it is in the pipeline, actually. Since people want to be able to, I'm going to bring back the motto. So connectivity redefined means that you should not care about your connectivity. Like the whole goal, and what I'm going to show you later demonstrating the product, is that you should not care about the uplink. So you should say, send my data, and you should not be your responsibility for figuring out how the data going to go. And this, whatever we're implementing right now, is going to be accompanied with an IoT platform where you can actually concentrate the data from all the different uplinks. So that being LoRa, that being Wi-Fi, that being Bluetooth, that being 4G, that being NB-IoT, that you should not be your application concern. You should say, send my data, and then data will appear in your system. This platform is in development, is not really ready for showing or demonstrating yet, but it's in the plans and the roadmap. We're hoping by the end of the year to have something to show there.
Super. So I imagine that right now, how it works right now is that the network server sends the data to you and also to the platform, let's say the IoT platform, when they want to monitor their end devices separately, but from the network server.
We actually, that's another interesting thing. We don't really care about the device per se. We actually need to tap into the gateway.
Gateway, yeah. Got it. Perfect.
So it's just the gateway and your server. So we're just talking about the server because some people might not want to interrupt this connection between the gateway and the server, and they just want to try our platform, for example, without having to modify anything. In which case, for example, with the Think Stack, we have a pretty good integration, and we're planning a similar one with Chip Stack in the near future. You can actually go to our platform and specify your server address, and then issue an API key, and then we can connect this API key to the server and pull the data directly from there.
Yeah.
So actually, there's the ability of tap into the stream of your data without you having to modify anything else. Okay. But apart from that, we already have a system that, if you're willing to intercept that process, to add a proxy in the middle that is collecting just this metadata from your gateway towards the server. So this is already available as a choice. But if you don't want that, you're free to try another of these options I mentioned.
Perfect. We have another question over here, which is, so what is the priority to choose the technology? I mean, in the communication technology.
So
I think, yes, this is actually a little bit also of the story of how the Sprout became what it is. I'm jumping a little bit ahead right now, but I always prefer, more interactive sessions. So it's a very nice opportunity. It was funny. One of the first applications we tried to do with the Sprout was an application where somebody our customer wanted to do telematics in leisure boats. So you take your boat, you go out in the sea. If you are in the range of LoRa, you can probably send your telematics. It's not that serious. Some, sensor, weather data. It's okay whether data reaches or not. It's not exactly that critical. But then we started adding a lot more information in the system, and at some point we figured out that there's going to be some type of distress system, some type of signal that you really want to reach the other end, your application end. And this is where we started adding 4G on the same device. So the moment we did that, we could see that we had to redesign a little bit the messaging system. So which messages go through LoRa, which messages go through 4G, which peripheral should be on, and when should 4G be off. So this actually started to blend into what we had in mind with Ioannis. We should find a way to just program as developers one message to go live, and whether the message is critical or not, whether the device has enough battery to open 4G or not, this should be a decision of the device itself. So we ended up with this nice type of abstraction where you can design your messages, you can mark them as critical or not, and then the device itself will choose whether it should be sent over LoRa or whether it should be sent through another type of technology.
Super. And have you found you mentioned that there are many things going around on the back of this deployment. For example, those that you mentioned, that there are some customers that deploy like the same gateway but with different backend sites and integration. But additional to this, have you find like any additional irregularities in any of the deployment based on the analytics platform?
Yes, and they span throughout the whole range of mistakes on configuring things up to making things, not work good in purpose.
Okay.
Yes, we've seen this happening
Yeah.
a lot of time. The most common, which I will try to do it a little bit more technical. The most common problem is what I described earlier. People just grab gateways. They place them where they can place them, wherever they have, a couple of buildings available or something, and they deploy their sensors, and then they sit there thinking that, oh, you know what, LoRa doesn't work very well. And we were trying to convince them that there are so many things happening behind the network that, things are not that simple. We had cases where people were overreacting. They would see the statistics, they would read a few things online. They would literally place one antenna in the middle of the city saying that, yes, it's going to cover 5 kilometers and we're done. One antenna is enough, it should work. But there have been very, very interesting cases. One, very quickly, was a period of about 1 week that one municipality project in the region of Thessaloniki, which is a city of 1.5 million people, the whole infrastructure was being brought down by about 12, if I remember correct, Ioannis, 12 sensors working on spreading factor 12, 24 hours, just shooting messages every 2 seconds. And people were wondering whether the network is not working correctly, but thankfully we already had the platform there. It was in alpha version, and we could see these messages coming, so we could pin down, we could find where they're coming from and try to figure out what's happening. Another very common problem is using devices which that was actually in the early days. I'm sure it's still there, but LoRaWAN and certification processes are they're solving these type of problems. Using devices which come from the Wi-Fi world. People have a device which works over Wi-Fi, they see LoRa, they put a LoRa chip there and they say, okay, this is LoRa compatible. And then they bring out devices which don't really operate as the rules. They don't really apply the rules.
Audio or something.
Yeah, things like that. So it was nice. You could we knew these problems would occur, but having proof of the problem and actually finding where the problem comes from makes you available to, it makes all these type of solutions available to you.
Definitely. And I can say that you guys share the same vision that we have at RAK, that is make IoT easy for everyone. And that is one of the things that we also wanted to achieve with the WISLog platform, trying to provide a modular platforms that allows people to interconnect different type of connectivity to use the most convenient one based on the necessity that the application is having at the moment. And yeah, it's super nice to see that you also recreate that in your own way with the Sprout. And analytics, Kudzu analytics is one thing to monitor all the LoRa network performance, but we have the Sprout, and I suppose that you are using it in real applications. So which is the most relevant application you have developed so far with this board?
Sorry, I lost you for a moment. Can you please repeat?
Yeah, no problem at all. What is the most relevant application you have developed so far with the Sprout members?
Yes, actually, this is the point where I told you I think I'm jumping a little bit ahead. I think this was the first application that also blended in both the analytics and the hardware. Exactly because being on the sea, being out in the open, we started, initially just for testing to try to inform the device that your LoRa connectivity is not exactly good right now. So if you have a slightly more serious problem, then serious message, then maybe you should start switching radio again if there's enough battery. Other things that we've seen happening is seeing saturation on special, on channels that you can use on the network, and then try to inform the device that we know that it's supposed to randomly pick a channel for transmission, but we have tried to enhance this type of algorithm by giving some more information to the device that it looks like in the next hours the first two channels are over utilized right now, so try not to choose these channels. Okay. We're only doing this very tiptoeing there because we don't want to destroy the protocol itself. We just want to make things a little bit better for those devices.
Okay.
Let me also add so let me just also to come back to your initial question. So we started to develop Sprout almost at around this 2 years ago, and then we found out about WizBlocks last year. So that was the moment we realized there was something like this available at the time. So I mean, knowing you that you would be doing this kind of thing, then perhaps we would have piggybacked on you earlier. Let's say. We share the same vision on that. We actually want to make things as easy as possible and want to help people achieve into the product as quickly as possible. What we try to do, let's say, extra in Sprout is we try to minimize the distance someone we have to go from prototyping into production, which is very close, also to what you guys try to achieve with these WizBlocks. And the first project, the big project we tried with our device is the customer that Dimitris mentioned. So actually, this boat tracking, the one that goes in the sea. So this laser boat tracking. It was the first time, and this actually caused a lot of pain because this particular client, he was very eager to try things out, and he, even with the very first prototype board we just built and we just ordered the first devices, we assembled the first thing, he just wanted to put in production right now. He wanted to take it and go into the boat. He just wanted to, I want to put it in the boat and test it in the field, in nowhere. It's man, we need to go a proper testing cycle, try things out. Oh, I want to put it there, I want to try that. And to be honest, this kind of demand triggered a couple of other features we have added in our system. So one of the things we really want to be able to do with our device is to collect diagnostics from the field, if anything goes wrong directly on the field. So we had this kind of scenario, and then the client wanted to try the device right away. Even though we were reluctant, we'd say, okay, why don't we give it a try? So we built our own kind of kernel around this whole system that if something goes wrong and crashes the system, it collects a diagnostic at the end, at the moment this whole thing happens, and sends you back through whatever channels available, not only the stack trace, but the status of the peripherals, all these kind of things. So you can do post-processing in your lab at the end. So whatever you would normally measure on your lab, like voltages on your pins, last things that happened, diagnose these kind of things, will be collected and sent back to you for doing analysis. And this is one of the use cases. An additional use case there was a beekeeping project. So we wanted to be able to measure the temperature, weight of the whole bee colony and this kind of things, or alert us if somebody is stealing that hive and do this kind of thing. So this is another big project we are doing. And also some tracking in buildings, there are some old buildings in Syros. Dimitris knows a bit more because it's his region.
I think I'm not gonna say all the details because I want you to go through the demo for that.
Definitely.
But yeah, that's
I think before jumping to the demo, I would you can present that as well during the demo. What do you think? To talk about a little bit more about the portable gateway based on the RAK2287.
Oh yeah, that was a quite interesting project. How
it's super cool.
It's funny how many of the examples that we give during the sessions, they usually started, as a joke. Initially, I told Ioannis that let's embed all the pain and suffering of redesigning the radio systems, and Ioannis will give you a little bit more details during the demo about how also the RAK gateway kind of started as a joke, we needed a few gateways to write us up to test the platform, the analytics platform. We were looking at the Sprout and okay, let's make a gateway with this. I mean, we can do this. Yeah. Why not?
Yeah, as Dimitris mentioned, so we try to solve all the pain points of engineering, and one of these things is to have a proper power supply and something that can go down into super low power. So our device has the ability of going as high as to 1.5 amps on peripheral, so it can deliver high power if it's needed. but it can also go down to 10 micro, and we have an optimized version to 5 microamps when it goes in sleep mode. So it covers the full range of proper hardware down to low power devices. And we want to give it a try on our high power testers to try the other side of the spectrum. And it was about the time, so we're finished, we had the first prototype of the Sprout device in our hands, and I was trying to find out some reference designs to create my own gateway for the system. And that was about the time where I found out, like when I was thinking about all the pain of the RF paths I need to solve to make this whole happen, I just happened to jump on your module at the time. So the rack, there was a previous one, the rack 2247 initially, and it was perfect. It was exactly the size of our profile. It was exactly what we wanted. I ordered like 5 of them the next day. It came to my house, and we actually created an expansion on top of this in 2 days actually. So I designed the whole thing in a day. I got the PCBs like 1 week later, and then I also write the firmware another day. So we ported the packet forwarder from Semtech, and it was already in C. Our SDK is already in C, so it was easy to do all this kind of porting. And then it was super easy to connect this kind of thing. And with the unit 2287, if I remember the next gateway, actually we got even better power supply, and you guys put a GPS. That's perfect. Thank you. Yes. Reduced even further the profile of the whole gateway, and now it fits in your palm. It's really small. It's like a Wi-Fi gateway.
I think you will see through the rest of it.
Exactly.
In the demo.
Okay. Definitely. So yeah, we can jump to the demo just to avoid that we jump out of the time.
Sure.
You can share your screen, and I will put it here.
Great. I will start. Share screen. There you are. I will start with I have multiple monitors. It's okay. You will figure it out. I'll leave this to be your problem, Maria.
No, just select the monitor that you want to present, and that's it.
That's
here I
will from my side, I will quickly go through the analytics, and I say quickly because although this is, I think, is as important as the Sprout, I'm pretty sure that your audience is here to see hardware, and we would love to see embedded systems more than just seeing analytics and all these kind of graphs and stuff like that. Ioannis is going to go to a more hands-on experience with the Sprout. So this is the start of the analytics route that Kudzu is doing. As I said earlier, for those who probably came a little bit later, what we're doing here is we're gathering metadata from people's gateways. We organize them in groups, in networks actually, and we start showing people how their network actually performs. Now, probably we've seen, if you buy off the shelf gateways, you probably have seen something, quite similar. You can see gateways giving you some type of statistics directly from the gateway. But we wanted to go a step further and show to people that a gateway working correctly or not very good is way less than how your network really operates. So this is the first image you can see, the first image you see when you enter the platform. You can see, I'll just make you a little bit jealous, some of you, you can see where we are actually. This is the network we have in the island of Syros in Greece. A few gateways spread around the island, and what you initially see in the platform is the mathematical representation of the model of the expected coverage. So this is more or less straight out a mathematical model. You can go and click your gateways and see exactly how the gateway performs, and you can see good signal, obstructed signal, and if you go further away, you can see where your gateway is actually receiving, but you shouldn't really trust this because it's already quite far away. Now this is live representation of this, and I will start showing you a bit of what our graphs are doing, how we interpret this metadata, and what type of results we get from the metadata. And I will quickly jump back to this image to show you how we represent this data on the map. So right now there are actually four levels of graphs. As I said, I'm going to be pretty quick. I don't want to bore people with graphs, although probably you have enough engineers who love graphs in here. So we start with a typical signal to strength and signal noise distribution. Keep in mind that this is the distribution of the messages that your network has received. You can always jump back and see your specific, whoops, not enough data there. You can see specific gateways, but you can always, this is what we care about more, how your network operates, not just your gateway. Further on, you can see statistics about the channel utilization. You can see, for example, here one of the common problems that we find, especially in networks that a lot of people operate, developers switch on devices and test. Most of you already know that when you get a LoRaWAN device, it has the 3 first channels pre-configured, which means that it's going to be using these channels more often unless you really configure the rest. And you can see what type of problems this causes in networks, and also get some kind of alerts about this. You can see payload, uplink and downlink payload size. Again, we don't really look in the payload. We just this is also only data gathered from the metadata from the header of the packet. And I will just jump to where we start doing operations on the data. First of all, you can see rates, which is we think it's a very nice indication of what's going on your gateway and when actually this is happening. So you can see, for example, if you see some spikes, it means that I've been out sending a lot of messages and doing some tests on the network. You can actually verify this. You see I've been sending a lot of confirmed messages here because you see the rate, both the uplink and downlink rate. And further on, you can see heat maps of your traffic, which we find extremely interesting to show to people, especially when you deploy devices that have that send messages periodically. You can actually start seeing this on the map. You can see, you might think that your network is not saturated, but specific times during the day, you might start having some issues because of a lot of traffic. And I'm jumping onto what we think is one of the most interesting aspects that you can directly get from this platform straight away. These 2 top graphs, one has to do with the left one has to do with how many of your devices are being seen only by one gateway. Now, keep in mind, I usually say how many of your devices. It doesn't mean that you own the devices. It means that these are the devices which are being routed by your network. It might not be your devices exactly, but you can see how many of these devices are being seen only by one gateway. And you can right away combine this on the right side with seeing which gateway is actually routing a lot of unique traffic. Now, this is where things start becoming a little bit more interesting, because exactly you can see which of your gateways are actually more interesting, more critical for your gateway. Just by taking a look at this specific network we have here, you can see that 50% of the messages of the devices working on the network right now are only seen by one gateway, which means that your network is already a bit critical. And actually, if you lose this gateway, this one single gateway here, you're actually losing 35% of the traffic. Now, this is a very, very common scenario we see, especially when people deploy networks, especially when people who deploy the networks don't really know enough about LoRa or about telecommunications in general. So they spread their networks in the city and they think they have enough coverage. But then once you switch on the end nodes, you can see that most of the messages, for example, might be going through this or that gateway, which means that this gateway is actually quite critical. Further on, we do some time on air and average duty cycle calculations. You can see that devices might be using a higher spreading factor in specific channels, so you can figure out where on the band where your traffic is actually most important. And this is something I shouldn't be showing because we are really violating the TTN fair access policy violations. We are actually doing this on a quite safe way and with communication with the people from TTN. This is caused by a lot of tests being run in the area here, but it's also a way to actually show that you can actually grab this type of information from your network by just throwing a look on the analytics platform. Now, as I said, you see 3 tabs here, but I said earlier that we have 4 types of information. The latest one is where this one is where, again, things are becoming more and more intuitive, because what we try to do is grab all the grab information that, like the ones I showed you before, and actually map them on the map so that you can say exactly where the problem is. So if you, for example, see traffic on your heat map, by this tool you can see where exactly is your traffic when this phenomenon happens, or if you see, for example, that some of your channels are being overutilized, we think it's very useful to see in which parts of the city this happens, so that you can go there and add more infrastructure to support your applications there, support them a little bit better. Now, last but not least, this whole thing comes with a reporting platform. So you can go here and actually choose what type of information you want to see for your device. And in the end, if everything goes wrong, if you have problems on your network that you cannot really figure out what's going on, you can always just send us a message, give us a range of your data, and we will take a look on your data and try to give you a little bit more information about what's really happening. I'm finishing up, hopefully quite quickly. We have a system that we gather all this information and we try to actually map it on the mathematical model in order to give you a comparison between what the coverage should be, but the coverage should be based on the location and based on your antenna height and stuff like that, but also how your gateways actually perform with regards to your existing network, with regards to your traffic and how your network is being used. So we have a system where we actually name this by full reach and potential. With the red lines, you can see the potential of the gateway, which usually matches exactly the coverage, and the full reach of the gateway, which is a representation of how far is how useful is your network in this in the vicinity of this area. So this is more or less it. This is, of course, just the beginning. It's going to be quite available pretty soon. We already have a few customers running it and a few more on test side. Oh, actually, I went a little bit too far.
Inception.
Yeah, that was an inception. Great.
So Dimitris, a quick question. I think some of
Yes.
our listeners know platforms like CloudRF. How do you compare CloudRF to your platform?
Well, CloudRF is an amazing tool that helps you figure out what your reception is going to be. Where, I mean, if you place your antenna here, where is your reception? But we go a few, actually, not just one steps further, because in the end, what I described is that we actually gather all this metadata and tell you where your network operates and not just where your antenna is supposed to reach. And we have a very, very definite distinction between these two. First of all, because what I said at the beginning, a good working antenna, an antenna really high on a mountain or something like that, overlooking the city, doesn't really mean that you have a very good network running there. The network is a combination of a lot of stuff, like where is your traffic, when is your traffic, do you have event-based devices, do you have devices running on a tactical period or something like that. So yes, I think that the distinction is between how your mathematical model should operate vs how your network really operates.
So yeah, CloudRF is just like, let's say, a layer on top of what information we already have. So it's like we want a bit more, we can provide a bit more rich information in that particular aspect. Plus, our system runs in a GPU in your machine, which means that that's something like preview, which is going to come in a while. You can actually do interactive planning where your gateways could be, and it does real-time solving all possible combinations while you move your gateway in the future. So it's like we're borrowing some features of CloudRF, but still we're even planning perhaps in the future to like piggyback on CloudRF. We're not replacing, let's say, CloudRF. We're using some of their features, like duplicating.
You know, the question that always came to my mind was, if you check on the map and you see that there's a network there, let's say it's whether it is a TTN network or a Helium network. I'm using these two because these are usually easy to represent. You can go on a map and see where the antennas are. If you see a kind of dense network there, how confident are you as a solution provider, for example, that the network operates good enough to base your solution on top of it.
Good. Yeah.
So this is the exact question we're trying to solve with this analytics platform.
Great answer. Good.
Nice. So we have like 10 minutes to make a product. Can we do it?
Yeah.
That was the challenge,
So,
right?
Let's try to make it in 5 then, I would say.
Okay.
So,
are you going to share your screen or just with the? Okay.
just the video. Just maximize my video. I'm just going to show you through the video.
Okay, perfect.
Cool.
So let's do this as quickly as I can, and I'm gonna try to go through this so we can get catch up with the Q&As. First of all, I'm gonna try the simple problem. So I'm gonna try. Let's say we want to create a sensor, and the simplest sensor we can do is like an LDR sensor, right? So I went ahead and wired like a typical rig that someone would have. So it's like an LDR resistor with an actual resistor, so you can create like a voltage divider. And then we want to make this whole thing a product. So like the big question is like, how does someone move out of like this kind of thing into a like device he can put on the field? And like, can we do this in under 5 minutes? So let's give it a try. So let's start by showing you our Sprout mainboard. So our Sprout mainboard, like similar like to your WizBlock idea, is a device that can fit in the palm of your hand. So this is our device. The idea is that the main board contains every aspect you're going to repeat on every hardware platform you're ever going to make. So this includes your MCU, your radio, like we have the Wi-Fi and Bluetooth radio inside this ESP32 chip, and the LoRa radio as a separate module here. It has all the power management required. So this device is quite versatile on the way it can be powered. It can be powered by like coin cell batteries, it can be powered by a LiPo battery. It can be powered by AA batteries. They're like holders on the edge. You can power your device by AA batteries. In this example right now, I'm just like powering it from USB. So let's say you want to develop your sensor like from this thing into like the final product. So first of all, our goal is to have a device which is ready to be placed in the field when you're done developing everything. So that's why our main board is designed with a proper mounting system. It's like quite industrial in the design, and it has all the peripherals you're ever going to need for going directly to production. And even like the connections are like made for being as compact as possible. However, how do you actually go from here down to there? You can start your prototyping session using like an expansion board, so you can actually put it on top and you can get things ready. Or you can go ahead and prototype in our expansion system. So our expansion system is designed with the concept of units. So you have like one unit here, and this is like a single unit size devices, like expansions, or you can even have this kind of double unit sized expansion. So this, by the way, is a tracking device for the boat thing we were discussing before. So there's like a GPS and LoRa, and a 3G device with a SIM card that you can use for tracking your boat. So I went ahead and I cheated a bit behind the scenes, and I converted this into our breadboard into this. So we have our LDR sensor, and I have a LED for playing around, and then I have my device. So I'm just gonna go ahead, plug it on my my expansion. And usually, so what you do, you just like when you're done creating your hardware, when you go ahead and open your IDE and start developing. So we wanted to minimize the effort someone has to do to start writing the firmware, because as we said, we also want to simplify hardware and firmware development. So by opening up your browser, you can directly go ahead in your sprout.local, that's like the website where you can find your device. It opens an access point while you're still in development mode. And from this access point, you can actually see the configuration interface. This is like a fully fledged configuration interface. Just a brief break here. So as I discussed before, the goal is to make the developers focus only on what matters. In this case, I want you to focus to your application. This means our kernel is designed in a highly modular design, allowing you to create just another module in the system, and that's the only thing you should care. In this matter, we have modules that take care of all the power management. So if you want your device, for example, to go to sleep when everything is done, or you want to go to sleep when you have power failure, you can make your device, for example, to be constantly powered by something. Like in a boat case, for example, we had it to be powered when you turn on the boat. But I want it to go in standby mode when you just unplug it. So we want it to sleep only in that case. We didn't want to sleep all the time. But if we have our sensor, for example, we might need to care to make it to go to sleep when everything is idle. I'm just going to leave it never sleep now for the demonstration purposes. We also have a fully fledged system logging interface. You can actually see live whatever is happening on your device, so you don't really need to you don't need to actually have a serial terminal to find out what's wrong. And best of all, we even have like a web editing interface, so you can open the web IDE and you can go ahead and start scripting your own first device. So here, let me zoom in so you guys see better. This is like a hello world. You just like run this, you get back your response. That's it, hello world. So in our example, we have a sensor. The sensor is connected in some particular pins, and we just want to do an analog read on that particular pin. That's what you would do with Arduino kind of environment. So we have a very similar interface to Arduino. So we use the same kind of like API. So I'm just going to paste the example I wrote like a few minutes ago so we can speed up a bit the process. So here we see that we have, we're going to read the luminosity. And to read the luminosity, what we're doing is we are enabling the peripherals in order to give power to the external device. Oh yeah, I'm just like being in rush mode to get in time, and I forgot to mention a few things. So as I said before, the device is designed to go into low power. This means that some peripherals might be aware of that, some peripherals might not be aware of that. In order to make that possible in all cases, we have controlling systems, controlling rings around the processor that you can turn off entirely peripherals. And this is the case here. So you can choose to enable or disable peripherals. So when you're not using them, they don't actually consume any power. So when the module is activated, we're going to read the power. This is going to be working by reading the analog power, dividing by the reference voltage, which is 3.3. And let's print this. So this is like, I'm going to put my hand on top of the sensor. I'm going to move my hand away from the sensor. You can see that the value changes actually depending on where I put my hand. So we already have our sensor reading here. Now, the next thing we want to do is we want to be able to send this data over the network. As I discussed before, we want to abstract entirely all this kind of uplink logic. So I just go ahead, and what I want to do is I want to send my data. So I'm just go ahead and do a send data. And I just put something like, I don't know, luminosity, 1 byte, and then another byte would be the value of read luminosity multiplied by 255, so it can become like a single byte. I just go ahead and do a send, and the data were sent. Now, where did this data being sent? We go back a bit and check the network tab in our configuration system. We see here we have various uplinks and various drivers. In this case, we have the Wi-Fi uplink and the LoRa uplink and the Wi-Fi driver and the LoRa driver. So in this case, I've configured only a Wi-Fi driver, like a LoRa driver, and I've enabled the LoRa uplink. So what it actually did, in this case, I didn't have a Wi-Fi, just send them over LoRa. I can confirm this by opening the system logs and seeing what really happened. So the system is now busy. It's considering the LoRa as an uplink. The decision-making here happens based on the power consumption each one of these links has. And doing this, we actually figuring out which is the correct channel to send the data. So we see everything happen, transmission completed, acknowledged, not received, but we're ignoring. So let's do a quick break into this kind of sprint. So what we achieved so far. So using JavaScript, we created this single module that read the analog sensor and using the data uplink instruction to send the data. Technically, we're done, because right now, all the power configuration is going to be managed by the system. So if I go back here and say, hey, now I'm using LoRa as my uplink, that's it. I don't need to configure anything else. My system is going to be powered when the module is idle. So I just like select this option. Well, in this case, I'm just going to do this because when I plug it off, it's going to disconnect itself. And then I'm just going to have my whole device ready to be used. So that's it, technically. So we have our device here. You can see that this is already, so what I said, we can go in 10 minutes from like a prototype into production in the following sense. So the device here is compact enough to be placed in a case. So we have our prototyping board on top, the LDR sensor is here. So technically we can just go ahead, plug a battery, because the whole system, as we said before, is powered by a battery. I just like go ahead, put it here, and then the whole thing is ready to be used as, to be put in the field. I just disconnect this, and then automatically the device will go in low power mode now, and that's it. So our device is now ready and deployed on the field. So We just did it just on time. We didn't have enough time to do like a few things later, but technically
that's also my fault, right?
I think that
No
that
worries.
was one of the quickest demo that I have ever seen so
I
far.
think so, yeah. I think you have to play it in slow motion to understand anything.
No,
Well,
that's nice.
it's actually it's very very difficult a lot of times to show that. We've all seen, you can get a device from somewhere, write a few lines of code, and you can read the sensor. But what is really really meaningful here is that we just did this on JavaScript, and your device has already radio abstractions and power abstractions enabled. So it's actually, a device that you can put on the field, and you know how long its battery is gonna last, and how it's gonna use the radios for.
Let me quickly show you the RAK gateway. You didn't see that. I actually want to show you that. So I've been
I
sending
wanted to ask
data.
more about that.
Sorry.
Yeah, I wanted to ask you to present a little bit more about the gateway.
Yeah. I was about to say that. So this is the device I've been doing all my tests so far. So as you saw before, so this is our Sprout mainboard. Again, in the bottom, this is like the same device that you saw before. That's another print of it. And then this is exactly how you can create a whole gateway. This fits in the palm of my hands. And since all the power management is being abstracted and managed by the device down here, we can actually use a LiPo battery as a backup power. So we can even make this gateway UPS powered, let's say. So we can even have, like, if network goes down, it switches back into the power supply, and then we come back and just switches back into your Wi-Fi, into your power device.
Even if you go beyond the technicalities, just take a look about how the size of the rack concentrator fits the size of the device.
Yeah, actually, just like it fits perfectly the size. Let's
That
put
was
it here.
that was an amazing coincidence, actually.
It just like fits exactly. Now, and this is the previous design I just told you, which we had to install a GPS. But your version already has a GPS, so we can reduce it even further now and fit it entirely into our profile of our main board, which is like super exciting.
Amazing. And like, what are the plannings for the development of this gateway? Are you planning to sell it and produce it for the community?
We're actually planning to finish a few more extensions. So right now the device is Wi-Fi powered. It's Wi-Fi backed. But if you want to have a reliable gateway, you also want a USB connection. An Ethernet connection. But since we have designed our expansion system to be super free, we can design this whole thing as an extra expansion. When we add the USB and power over Ethernet expansion on top of the system, we can like stack the gateway and have the whole thing ready to be rolled. It's actually on my it's actually on our plans to have it roll down slowly, like the next few months. So there have been some delays due to the whole COVID situation. There were some delays to the manufacturing, and we're a bit back in our schedule. But
I don't know if you have heard anything about it.
I don't know.
All news to me. So on the gateway side, what do you do with JavaScript? Do you have to code anything for the gateway to work? Or?
No, let me actually show you what the gateway interface looks like. So it's very similar. So
this a few more minutes. It's fine.
Let's go to gateway. Let's go to the gateway interface. So you didn't have to do anything. Like, does it look familiar? By the way, this is like let me get myself outside of the. This is exactly the same interface as we had before, right? So we have like the same thing, the same interface as before. We even have a LoRa module that we don't really use here, but technically you could use this LoRa module to do a piggyback link. So you can actually use the LoRa radio to communicate with another LoRa gateway as a secondary channel. Just keep this in mind. And the only thing we had to do is we need to write a module, which is the LoRa gateway driver. That's a Semtech porting of the code we had to do, and then the packet forwarder, which is responsible for forwarding the data down to our service. And you will notice here that it's sending our data into our Kudzu proxy. And we can even see, like, we can open like the logs and see like if there's any lucky packet around yet. Yeah, we actually saw a packet here. That's it. That was like sent from my device right before. So you see live traffic coming from the gateway and being fed into the system. So this is let's say a few more technical details. The firmware is written in FreeRTOS, and our kernel system is like a custom kernel built on top of FreeRTOS. And we just had to, the CPU is ESP32. And the good thing we like on ESP32 is the fact that you can overclock it in 180 megahertz and behave properly like a gateway, or underclock it on 80 megahertz and then behave like a node. And this is like the best thing we managed to do here. So actually, we could not include in the same space like the gateway firmware and the JavaScript runtime. Unfortunately, it's quite big, but you don't need that to be able to have a fully functional, robust gateway. And the issue here is that we're using a dual firmware like system. So if anything goes wrong, we have like a fallback system. That's why we did not have enough space for having this kind of things there implemented. But yeah, with just like a few tweaks, we got from nothing into a fully functional gateway like in 1-2 days. That was like really great. Like the product was amazing. Like from our point of view, from the consumer point of view.
Great stuff.
Great, thanks.
Okay. Oh, you're
I'm
silent.
mute. Common thing. Yeah, thanks guys like for sharing all of these, like all the things that you are doing, like pretty awesome. I have a question regarding the radio module on the Sprout board. Are you planning to migrate that radio module to another one, or are you going to stay?
Oh yes. Actually, we heard that there are some plans from RAK to introduce like another. So the issue we had, let's say, with our particular module is that we're implementing our own stack, LoRaWAN stack, in our main board. So we didn't want like a fully heavyweight like an external full stack chip. And we heard that it's going to be a really nice new radio only module coming from RAK. And we're eager to trying it like as quickly as possible as it gets in production. So we're super excited for that. I mean, it's really excited because like RAK is following, like, let's say, the same thinking we had. So the moment we're saying, oh, we need that, then we find the module from RAK, and that's exactly where we want it. So
RAK is in your mind. No, I'm kidding.
You read your email, man. You read your yeah.
Yeah, definitely. No, that is awesome, and also thanks for sharing that with us. Dimitris have been jumping on the comment section, answering some questions. So thanks, Dimitris, for jumping on, so we can have more time to discuss over here.
I tried to make up for the time we didn't answer a lot of questions.
No problem at all. But yeah, you already like covered almost most of them, all of them that are right there.
Can you say that we are full stack LoRaWAN developers now?
Not yet.
Yeah.
You have to make the modules as well. That's your next challenge.
Nice. Okay, guys. I think that is like all for the session. Regarding like the giveaway for those who ask questions, we have like 2 AFTIC members asking questions during all the session. Both of them were Abby. Abby, thanks for joining the session. I had a chance to chat with you this week. Nice to see you around. And also, Corgi Man Geek. I don't know who you are, but I will contact you to find your identity. You will be receiving some rack mount for your workbench. So I will be contacting you to sending you one of our things. And yeah, I think that's all for the session. I think we need another session to discuss more things with you guys. One session is not enough.
Well, I really hope it's going to be interesting for more people.
So when we integrate the new RAK module, we're going to have more things to discuss.
Definitely. We look forward to that one. And yeah, thank you also, guys, for taking the time after like all this time, like waiting for you, and also for sharing your experiences and all the things that you have been done so far at Kutsu. It is pretty amazing, like the platform, also like the Sprout, and also now like the Gateway, like all the things are super cool. And please never stop making cool things as you have been done. And yeah, I'm pretty sure that this is going to be like a great interest. Like all the things that you shared today are a great interest for our community members. And yeah, I don't know if Jose, you want to share something else, or
I'm
Ioannis
just
or
breaking
Dimitris?
stuff here in the lab. Sorry. Yeah.
That is the day today.
Thank you very much, guys. It's been
Great.
always welcome
Thank you.
to see
Thank you for hosting. And
No.
hope to see you
Exciting,
again in the
guys.
live sessions.
Amazing,
Thanks.
amazing. Also, thanks to all of those who connect, who stayed during the entire session. We had a good number of viewers during the entire session. That is awesome. We keep increasing that number. So keep connecting every Friday. And if you have like any question for those who are watching this video later, feel free to ask your question. And Dimitris, Ioannis, Jose, or I will be happy to answer your questions later. We hope to see you all of you next week and enjoy the rest of your morning, afternoon, evening. And yeah, that is all. My best wishes to all of you guys. Happy hacking. Bye bye.
Good morning.
Bye.
Bye bye.